Now the base is the upper pin, and that goes to brown, black, red. That's a 1K. And that goes to there, which flips to this side, which goes to a lot of stuff. Now, I think that's 5 volts as well. And it is. So, and then the other side of it goes to those 2 resistors, I think. A cap and a resistor. Yep, cap and a resistor. Now, just from previous experience, I'm willing to bet the cap goes to ground. Yep. And the 1K resistor also goes to ground. So there's a voltage divider on him. Now this cap, there, if you can read the numbers on the side and go look at the table, you can translate it back to what it really is. I'm not super all that interested at this point, so I'm just going to say screw it and leave it be. But yeah, this is really interesting. They got a voltage driver on the base, and I don't see any other connections off of that. Oh, maybe that goes to the base. See the no connection. No connection. Aha! There is the connection I missed. This resistor here, which is the 4.7K pull-up, right here, there is a connection tapped off of it that goes over to this cap. So my guess is this is some sort of biasing circuit for, either a photodiode or phototransistor or something else. So this sets up the bias, and then the way they actually do this when they put the light pen on one of these LEDs, the micro is sitting there scanning all the LEDs and blinking them really fast, one at a time, or some other search pattern where it goes this way first till it sees a blink on one column, then goes this way to find the row to get the XY coordinate of where the pen is. So the pen is picking up these really fast little pulses of light. So they need to filter out all the background light that might be going on in case you have the pen, just sitting on the side or pointing at a light, and only see the really fast little blinks. So this biases the circuit to get it into this quasi-on state, and then this cap here pulls off all the high frequency components coming out and feeds it into this LM393. I think that's an op amp, or a couple op amps. Oh, differential comparators. Sort of like an op amp, only a little different. So the comparator sits there with a window, and when the signal goes outside of that window, depending on, it's either a single point window, when you go above it turns on, when you go below it turns off, or if you chain a couple of them together you can make a dual point window, so when it's in between the points it's on, and when it's outside it's off. So let's trace this back. So the other side of the cap, I think this is +5, has a white, brown, yellow. So that's silver. No, white, brown, yellow. So that's like 9, 1. Nine. So this is a 910 k ohm resistors. So that just sort of biases this cap. So you got both sides of this cap sort of pulled up, and when you get pulses coming in here, it's going to pull this side down, which will instantaneously pull this side down while this capacitor changes its charge. Once this discharges through here and equalizes, he turns back into open circuit, and the pulse will go away on this side as well. And that, I saw on this side, goes into the third pin. Okay, so let's go see what pin 3 is. Pin 3 do they have a good picture? No, they don't. This is about best. Pin 3 is in plus, pin 2 is in minus. So plus, minus, and out is pin 1. Plus V is pin 8, and ground is pin 4. Alright, pin 8 is plus 5 volts. Yep. And pin 4, 5, 6, 7. 5, 6, 7. Oops. Plus 5, 6, and 7. And pin 4 is hopefully ground. Let's check that real quick. 1, 2, 3, 4. Yep, pin 4 is ground. 5 is in plus. Okay, since I'm on the top side real quick, I have pin 5 is tied to plus 5 volts. Pin 1 sure goes over God's green earth. Okay, that's pin 2. Pin 2 is no connected on this side, and it must come out somewhere over here. I'm guessing right there. Nope, guessed wrong. Okay, 3 resistors and a cap off of pin 2. So I'm just going to draw this down to here. Cap, resistor, resistor. Okay, the first resistor is a 7.4, is another 74K. 74K. The second resistor is another 910K. And the cap is another little picofarad type unit. Now on the back side, cap and that resistor are tied together, and that looks like ground. Yep. Now the 47K feeds back to pin 3. So this is some sort of input BIOS / filter circuit. It generates a voltage divider between this, and this, with some high frequency bypass across the minus side of the part. Now I wonder if there's feedback. Oops, wrong part. Between the output. Yeah, there's no feedback on this part between the output and anything else. Now pin 1 hits that resistor right there and then shoots off that side. So pin 1, where does that resistor go? Is he ground? Nope, plus 5 volts. 7.4K. Yep, 7.4K. 7.4K. And then aha! I think that goes over to that flip-flop. So we may be able to nuke this flip-flop yet. So if I tap on to pin 1, which is the output, pin 6 of the 297. Pin 6 of the 297. So 297, pin 6 is the input, the set input of the flip-flop. So when this pen detects an input, it gets BIOSed by this transistor, massaged by this op-amp or comparator, and then latched by this chip and fed back into the data bus when the processor comes around to scan it. At least that's my assumption. I need to follow the other side of this. I'd have to follow the other side of this 297 back, which isn't a bad idea since I'm going to want to know that so I can know the other end of the trace is not in use. Boy, this thing just sort of goes everywhere in God's green earth. See, I sort of get up to this point right there. Nope. Well, I know it's right there. So now the question is, oh, it flips out right there. I'm guessing. See, this is where it gets tough. My eyes start bugging out. Nope. Nope. God, I would swear it was this one. So right now I'm just sort of scratching the top copper, or the pro coat off the trace, so I can just poke through it and hopefully get lucky and find the signal coming through here. Now, before I get too far, I should look on the back, and there is. There's a pad underneath that part, and that's my signal coming through. And then it comes down into pin so it comes into this 125. So I just want to mark that so I don't forget later. Oh, come on, I just found it. Three over. So this pin right here is the pen input from this flip-flop. Now, the clear input also probably makes a trek halfway across, or the reset input also probably makes a trek from somewhere halfway across the board. Yeah, it's right there. So now so when it sees the pulse, it gets filtered, latched in here. The micro reads it and says, "Oh, I saw a pulse here over my LED," and then it pokes this to clear out that result. Now, I think it's coming off of the bottom edge of that 138. Or not. Bottom edge of this 130. Lost one. Two dots right next to each other. Now, if you were doing this on a multi-layer board, you'd be doing this sort of pin by pin probing a lot more, because right now I'm tracing, so there's the reset input to the pen. Right now I'm tracing a lot just visually to sort of get me close, where if you had the multi-layer stacked up board, I mean, most of the traces you couldn't see because they're inside the board, so you'd have to sort of clip onto one leg of one device and then sit there with either a little brass brush or your probe and just go over all the chips on the card until you get lucky and find the one that beeps, and then narrow it down to the exact pins you need. So now with that amount of debug,